so primitive in so many ways that scientists felt like they could just reach back and touch the common ancestor we shared with chimpanzees.
Here was an anonymous human ancestor that had sort of lain in suspended animation for over 3 million years.
It's been 50 years since Lucy was discovered. This is her golden anniversary. The great thing about an anniversary like this is it can help us take task of what we've learned. What we knew before Lucy wasn't a lot. The first fossil found in Africa, researchers didn't believe for a long time that it was a member of the human family. They thought maybe it was an early baboon, but it wasn't until the 1950s that researchers began finding fossils in East Africa that showed that there were members of the human family dating way back to at least 2 million years. So the big revolution of Lucy in 1974, when Don Johanson and his student Tom Gray found her, was that she was 3 million years old.
It was the middle of the day. It was hot. It was well over 100 degrees. I happened to glance over my right shoulder, and I saw a little piece of elbow that allows you to flex and extend your arm. And as we looked around, we saw other pieces. We saw a couple of shards of a skull. We saw fragments of an arm bone. We saw fragments of a lower jaw, and that clinched. I knew immediately this was some kind of early hominid. One of the members of the expedition said, "You really think it's a female?" I said, "Oh yeah, I mean, the length of the thigh bone is only about a foot long. Well, maybe it's a child." Well, we looked at the teeth and saw that the third molars, the wisdom teeth, were erupted. So this was a mature adult. And she said, "Well, if you think that, why don't we call her Lucy, after Lucy in the Sky with Diamonds that was playing?" And I thought, my gosh, I've just gotten my PhD. I need to find what its scientific name is. But it was too late. What bothered me was she was found in Ethiopia, and she really deserved an Ethiopian name. We had members of the Ministry of Culture at that time come to visit the site, and one of them said, "I think she should be called Dinkinesh." And Dinkinesh in Amharic means "you are wonderful." And she certainly is.
What do we see in her face that we recognize that looks like us? What is it in her smile, right? One, she's walking upright, okay? That is a defining feature of being a member of the human family. We know that from her pelvis and her knee. Her species' brain is beginning to get bigger. It's still in the size range of an ape's, but it's actually appreciably bigger. We thought we were right at the horizon of when the human family was born at about 3 million years. Of course, a lot of new discoveries changed that picture. For 20 years, she was the only game in town. She was it. She was the oldest member of the human family and seen as the sole lineage around at the time.
As we continued in following years working at Hadar and others at other sites, there are well over 500 specimens of this species over almost 1 million years of time. This was a highly adaptable species that could live in a multitude of environments. It's known from Ethiopia, from Kenya, from Tanzania, and it has become a reference collection whenever new things are found.
They give us a good sense of how much variation to expect in a single species. Because that's usually our problem in paleontology. We find one mandible or two teeth, and all the subtle differences that we see comparing with others, they look like they're taxonomically significant.
One of the big revolutions since the early 90s is we finally have found fossils that are older than Lucy. In rapid succession, we found Australopithecus anamensis that looks a lot like Lucy, but that's more primitive. Then, right after that, a team found fossils of Ardipithecus, which is a more primitive hominin. In the middle of the desert Chad, a French paleontologist found fossils there of something called Sahelanthropus chadensis. And while they didn't find leg bones that proved upright walking, they found that the way the skull sat atop the spine suggests upright walking.
That's when things became like really clearer. Lucy was not the hominid species that came right after the split from the common ancestor over here with chimpanzees. Now the split is probably like close to 8 million years ago.
Researchers have started finding other fossils that were not only older, but also that were alive at the same time as Lucy.
In 2001, they announced the discovery of a species called Kenanthropus platypus from Kenya. We found the Brutale foot, which then again brought up a totally new question. Why do we have a foot with a puzzle big 2 at 3.4 when we expected all of the hominids at that time running around with human-like foot? When we found Australopithecus remida, the idea was, well, maybe we're going to find more of Australopithecus afarensis from this time period, or we're going to find something that belongs to the Brutale foot. The discovery of all these species kind of made Lucy like shy of being the sole ancestor of everything.
The human family tree, it used to be a very simple bush with a main trunk leading from Lucy down to our family and others. Now it's beginning to get more filled out. I wouldn't say it's a super bushy tree, but there are other fossils hanging on different branches, and it's not really clear which one gave rise to our genus Homo. Lucy is still the best candidate, right? We have a lot more of her, and she has features she shares with us. But was there another fossil in between, another species in between?
We now have a partial jaw, which has been dated to 2.8 million years ago. And they think this is the earliest Homo. Maybe we will find at some point something that's older than 2.8 million years ago, which could represent the first appearance of that genus.
It puts early Homo around at a time when we start to see other species that were alive. Maybe other species could have been ancestral or interbreeding at the edges. That's the big mystery right now. So the thing that's changed the most in the years that I've been covering human evolution for science is not so much how we actually look for fossils, because that's pretty basic.
I'm sad to say that the only way to find them is to go out there under the African sun and walk and look and look and walk and hope that your eyes fall on something.
Once the fossils are discovered, the tools that are put to try to reconstruct not only the fossil, but to reconstruct the ancient habitats and dates and geology are tremendous.
What we had were like calipers, measure teeth and measure cranial capacity. Now we have CT scanning technology. You can study not only the external morphology, but also the internal morphology, the shape of the inside of the brain, which we couldn't do before. We now even have started extracting protein from bones that are as old as 2 million years from South Africa.
Ancient proteins are helping us look back in time to tell if things are from the same species or not.
Are we going to be able to push that technology to actually sample protein from like 3 million year old fossils? The technology has changed, not only in terms of how we study the bones, but also in terms of how we analyze the environment in which these early hominids lived.
These teams also bring in people in different disciplines that are studying the ancient geology, the volcanics for dating. And then they also look at the isotopes from the teeth of the animals and the hominins, can tell them what they were eating. They can start to build a picture of the world, of Lucy's world, let's say.
3 million years ago when Lucy lived, it was not dry. It was much higher in terms of altitude, and there was a lot of water. There were lots of animals that we don't see today in the region. They tried to divide their habitats. Not every animal lives in the same habitat. If they did, there would be a lot of competition.
The way fossil hunting has evolved over the years that I've been covering human evolution is also very exciting. There are now Africans, Ethiopians, Kenyans who are leading teams doing research in their country. So it's not just this rush of foreigners coming in to treasure hunt and find the best fossils.
This whole celebration of Lucy 50 is not just about Lucy. It's also about thinking about the future. Her discovery, for example, in Ethiopia, has built a wonderful laboratory. We need to do the same in other African countries with a lot of fossil wealth. Local scholars get involved in those kinds of research that we do. It's our advantage.
The human story is so complicated. It's not this simple, neat line of one species evolving into another to become us.
The tree is going to change again somewhere with new discoveries. But by and large, afarensis continues to be the last common ancestor to those later branches on the tree.
Lucy is one of the most important players and will always be. She persists as a really significant member of a really significant species